Okay, so your bell work today is to answer these 3 questions in your math journal. I put a picture here for reference, and I say answer the questions below in your math journal. What is a parabola? What is a hyperbola? And what is the difference between them? So, let me back up here. Our lesson today is over hyperbolas. This finishes our chapter before our test, 10-5, and we're going to learn to graph a hyperbola, and we're going to learn to find and use the foci of the hyperbola, and we'll use those to graph and to create lessons and such. Not lessons, excuse me, equations. So, what is a parabola? Can anybody answer that? Yes. U, but if you take the branch or the arms of the U, you've got to stretch them out a little. So as it goes out into space, it's going to go to positive infinity and negative infinity on that horizontal axis, right? It's going to. So when you talk about the domain, you're talking about all real numbers because it goes further and further out. Now actually that's more of a V. They're more rounded than that. Okay. Now when you talk about a hyperbola, you're talking about 2 of those, right? So if we take this plane right here and we take these, it's sort of a 3D picture, but I'm trying to make this look real. You've got a mirror image of these parabolas, and 2 of them together, like this in a mirror image, make a hyperbola. Okay, they're in the same plane. So if we can find measurements like from here to here, if we know this measurement, we can say, okay, well, there's a vertex of this one, and there's the vertex of that one. And if we learn some other things, like how wide are these areas, you know, what kind of slopes do these angles have, we can learn to graph them quickly. So the difference between them, there's 2 of them, right? And so today we're going to focus on the hyperbola. There's some key concepts in which this is being recorded, so you can go out there and shoot pictures of this later. There's a bigger one that I'll have you take a picture of in a moment, so I'll make sure everybody has it. So here's the essential understanding is like the ellipse, the hyperbola shape is determined by its distance from 2 foci. So when we get F1, there's our first focus point, and our second focus point right there, F2. So it says a hyperbola is a set of points P in a plane, there's our P, such that the absolute value, so when we talk about absolute value, we're just talking about the distance. So you could replace that word with distance, such that the distance between these distances from P to 2 fixed points, F1 and F2, remain a constant, K. So if I do that and that, and we subtract those 2 lengths, we're going to be left with the difference of K. Right. So from here to there minus from here to here is a constant K. And we take the absolute value because we're talking about measurement, distance. So whether it's positive, negative, here it would be negative because this minus that, this one's obviously longer. It would give us a negative value. But we're talking about distance, so that's why we do absolute value to make it positive. So that's equal to K. So K must be less than F1 times F2. But we don't run into many cases today where we have to check that. We're just going through the first couple of problems, and then we're going to be done. So each fixed point F is called a focus of the hyperbola. So this is the focus of a hyperbola, and that's the focus of a hyperbola. And notice here, you've got those same 2 angles. And if we were to subtract those from each other and take the absolute value, it's still going to be that constant K. Now this, I'm not going to read through all this, I'm just going to point out a few things. So hyperbola consists of two smooth branches. Each arm of this, that's a branch, and this is a branch, and they're smooth, and they have a smooth connection. Where they meet at the middle is called the vertex of the hyperbola. And then here, this one meets there, and they meet right there. That's a vertex of the hyperbola. The segment that connects the two vertices is the transverse axis. That segment is the transverse axis. It lies on your axis of symmetry, right? So if we were to squeeze these in the direction that they're curved, squeeze them in, right? That's a horizontal hyperbola. So axis of symmetry, transverse axis. The transverse axis also contains your focal points. The center of the hyperbola is the midpoint between the two vertices. So we go there and there. If they tell us that this is 10, then we know that there's the origin right here is your center, so that means this is 5 and that's 5. So if I had to tell you, if they tell you that this transverse axis is 10 units long, then we can say, okay, well, the vertex on the right is at 5, 0, and the vertex on the left is negative 5, 0. See? So we'll use it like that. So the center of the hyperbola is the midpoint between the two vertices. Here it's just the origin, and for all of our problems today, it's going to be the origin. So just for the ellipse, the foci are positive, negative, C, and 0. And the distance between the two foci is 2C. Right? So from this point to that point is 2C. So if they tell you that C is equal to 16, then you know that this is the focus point on the right is at 8, 0, and the one on the left is negative 8, 0. Okay? So quite easy math that we deal with here. The vertices are at positive, negative, A, and 0. So that point right there is A, right? A, 0. And that vertices right there, or vertex right there, is negative A, 0. Okay, the distance between the two vertices is 2A. See, right from there to there is A, and from there to there is A. So both of those together is 2A. So we can also say, I'm not going to go through all this, that K is equal to 2 times A. So there's another one. Now, in a standard hyperbola, C is related to A and B by this same equation, C squared equal A squared plus B squared. We'll be using this a lot today to get A, B, or C, and then we can construct our formulas and then, or our equations, and then we can construct our graphs. Could you let her back in? Or actually, I better see if she's okay. I'm going to pause this. The length of the conjugate axis is 2b. Are you okay, hon? Do you want to go to the nurse?
No.
Okay. All right, so, well, let me know if that changes, okay? The length of the conjugate axis is 2b. So the conjugate axis is this one, right? So if this is our transverse, the transverse is the one that runs through the foci and our axis of symmetry. Then the one that runs perpendicular to that is called the conjugate axis. Okay, so if the length of the conjugate axis is 2b, so if they gave us a length of 6, then we know this would be at 0, 3, and this one would be at 0, negative 3. Right? If they tell us the length is 6, then you're going to divide it by 2, and you know this side's going to be half of it, and that'll be the other half. So when we get those, we'll learn to quickly graph these hyperbolas. All right, so here's what I want everybody to shoot a picture of real quick. If I could print this out and put them on note cards in color, I would do that and give them out to my students every year. This is sort of like what I call your cheater sheet that gives you everything you need to know. All right. So I want everybody to look over this quickly, and then we'll quickly talk about it. No, well, I'm not going to walk across because you're all shooting pictures. Almost. Got a couple more pens out. Down to 3. Down to 1. Okay, now put your pens away, please. All right, so this is the, let me get out the wall. This is the last little bit before we're going to work a problem. So the horizontal hyperbola is on the left and the vertical is on the right. And like I said, if you take these arms and you start pushing them in to fold them in half, that's the axis that they're going to wrap around. So these would wrap around the x-axis, which is horizontal. So that's the horizontal hyperbola. This is just how I remember them. There's no official rule. I've never seen that in a textbook. It's just how I remember, because I'm a little weird like that. Now here are these on the vertical. If I fold these on the vertex and push them in the same direction they're going to end up around the y-axis, which is the vertical axis. So that's the vertical hyperbola. All right. Now, this looks like a lot of stuff, but it's really, if you have this, it makes your homework like just so quick. So if we notice that there's all the things we just talked about, one new thing that's on here that we didn't was the slope. So we've got these lines, and we've got a box here. But if we know the transverse axis and if we get these few measurements, we could draw this box, draw lines through the corners, and then get your vertices, which are at the edge of the box, right? And then you can quickly graph your hyperbola like that. And that's what we'll be doing. All right, and all you have to remember is we just have to keep finding A, B, and C, A, B, and C. And we get those with that formula, C squared equal A squared plus B squared. Right there. All right, so once we do that, we'll solve by plugging in some values depending on what they give us. So if they give us a vertice, a positive, negative, 3, 0, well, then we know we've got our A values. And then they might give you the vertices and the foci. So then you would have your A and your C values. So you would plug the A and C into this equation and get your B, and then you're basically quickly done after that. All right, so we'll learn how to use those in just a moment. All right, and then it switches a little depending on if it's horizontal or vertical. And notice the difference between the horizontal and vertical equations. On this one, you've got x squared over a squared minus y squared over b squared. Okay, now look at the vertical. What changes here is our y squared and our x squared. See, the a squared and the b squared and the 1 and the minus sign are the same in both. The only thing that switches between the two is for horizontal, it begins with the x squared minus y squared. And for vertical, it's y squared minus x squared. You want to go to the nurse? Yeah. Okay. All right, so read this, the rest of this for me, and study, and I'll come back. All right, so let's go ahead, and this will be on the video, so you can pause it at home if you didn't get it on your phone or you need to get more about it. So you can get that tonight at home. All right, so let's look at our first problem. It says because symmetry for both the ellipse and the hyperbola, because of symmetry for both the ellipse and hyperbola, the value of C is half the distance between the two foci. So that's just a little hint. The value of C is half the distance between the two foci. So if you have your two focus points and you see that that's at -5 and that's at 5, and you've got, actually they do it backwards. They're going to give you the distance and ask you to find the foci. So let's use that here. Writing and graphing the equation of a hyperbola. A hyperbola is centered at 0, 0 and has a vertices of positive, -4 and 0 and one focus of 5 and 0. So what is the standard form equation of the hyperbola? So if we know this is hyperbola centered at 0, 0, so the center is there. It has a vertices of positive, -4 and 0. So at 4 and -4. So that means this is a horizontal because everything's on this x-axis. So all the things that we're going to get is from the horizontal hyperbola. Right? And they gave us the vertices, the vertex. We've got that and that. And one focus of 5, 0. So at 5, I think that was 5 and 0. So what is the standard form equation of the hyperbola? So do we have our A's? What is the vertices on the horizontal? If we look back, the vertices is your A. So we know that A is equal to 4. And our focus is 5, 0. So I'm going to go back again and look at the focus. Our focus is C.
Wouldn't the focus of 5, 0 be on the x-axis then?
Yes, thank you. Good call. All right, so there's your focus. I'll put a little X there. Okay? So we've got our A and we've got our C. That means we'd have another focus where? At -5. We'd have another one right there at -5. They gave us one of them, so the other one is on the left. So we can say the vertices give us A for the horizontal, so A is equal to 4. And because they gave us one of the focus, it's at 5. So C is equal to 5, A is equal to 4. Now, excuse me, we have to find B. Remember I said all this is about finding ABC, ABC? So we're going to plug this in to our equation, C squared equal A squared plus B squared, and solve for B. So, excuse me, we have 5 squared equal 4 squared plus B squared, right? So that's 16, 25, 16 from 25. So we end up with 9 equal B squared, that's a 9, and take the square root of each side, and you'll get that B is equal to positive, or actually B is equal to 3. Okay? So now we have A, B, and C. So now they ask us to write the equation. So let me highlight these. B is equal to 3, A is equal to 4, and C is equal to 5. There they are, A, B, and C. Now we're just going to plug it into that hyperbola equation for horizontal hyperbola. So it's x squared over A squared minus y squared over B squared equal 1. So now replace your A, B, and, well, your A's and B's, right? So A is 4, B is 3. So it's x squared over 4 squared minus y squared over 3 squared equal 1. So now simplify. So that's going to be x squared over 16 minus y squared over 9 equal 1. And you're done with this portion. We've got our equation. So we gave them the standard form equation of the hyperbola. And there it is. Any questions about that? So pretty easy stuff. Okay, let's look at the next one, and then we'll work some. It says sketch the hyperbola, use a graphing calculator to check. And we're not going to use the graphing calculator to check today. But draw the horizontal, transverse axis, vertices, and central rectangle. The central rectangle guides the drawing of the graph. It shares the center with the hyperbola, and in this case has a height of 2b and a width of 2a. If the hyperbola were vertical, the dimensions will be reversed. So that's your first step. So let's do this. So we know, let's see, let's go back to our A, B, and C. A, it's 4, 3, and 5. Okay, so we're going to draw. So we know that the height is 2b and the width is 2a, right? So b is 3, so your b, that's always going to be the one that's perpendicular to your main transverse axis, right? So if they told us b is 3, then we're going to go from the origin up 3, right there, and down 3 from the origin. So we know we've got that. We've got the top of our box. And now let's do the side. We know that a is equal to 4, so we're going to go from the origin to the left 4 and to the right 4. Now, draw the rest of your box. So that's your first step, is to draw this box by those two values. Now, through the corners of the box, draw a line. So it's going to come through, oops, I'm not drawing it very straight, through that one, and then draw this one. Straight through the corners. Now, those are like your asymptotes, right? They're going to get really close to those lines but never touch. Now we know the vertices are at 4 because that's our A value. So mark those, 4 and -4. And now draw your hyperbolas. So it's going to go like down to the vertex and then swing back around. And same thing over here. In those X's, as it gets further and further out, it's going to get really, really close but never touch. So that's how you draw it. So like I said, if you can just get your A, B, and C, you've got everything you need. All right. Any questions over that? All right, so open up your workbook to 10-5. And let's do this first one together. We're doing good. Okay, so take a look at this first problem here. And I'm going to go grab my book and I'll be right back. So let's work the first one together. It says find the equation of a hyperbola with the given values, foci, or vertices. Okay. Assume that the transverse axis is horizontal. So don't we love that? You can just work with that left side equation that we had, right? So they give us b equal 3 and c equal 4. So we know that we have to find what? A. So let's plug that into the equation. They've already written it for you on the right. It says use the equation c squared equal a squared plus b squared to find a squared. And here it is. So plug them in. So we know that c is equal to 4. So it's going to be 4 squared equal a squared, which is our unknown, plus b squared, which is 3. 3 squared. I know I'm marking that up. So here it is right there. Now let's do the math. I'm just going to do this out to the side. 16 equals a squared plus 9. So subtract 9 from each side, and what do we get? 7 equal a squared. So we know that a squared is equal to 7. So you could say that a is equal to positive negative radical 7. You could say that, but we're also going to use this as an a squared, right? So we're going to just say a squared is equal to 7. Okay. Next, we're going to substitute the values for a squared and b squared. So let's write our equation. It's going to be x squared over a squared. Oh my goodness, I cannot write with this thing. Try it one more time. X squared over a squared minus y squared over b squared equal 1. Now substitute. So we know that a is equal to 7. Excuse me, radical 7. So a squared is what we're filling this in with. So that we're going to fill in with 7. B squared is going to be 3 squared, which is 9. So it's going to be x squared over 7 minus y squared over 9 equal 1. And there's your equation. And that's all there is to it. So really, we didn't even have to take it down to that. As long as you have your a squared here, you're good. A squared was equal to 7. Okay? That's all there is to that. So you will work 2 and 3 just like that. But remember, they're giving you different things. So here, they're going to give, on number 2, you get a B and a C. So you're going to solve for A. Your A is your unknown here. And over here, they give us the foci and the vertices. So let's look back at what foci are and what the vertices are. So foci are the C and vertices are A. So our unknown here is our B. Okay, so you'll solve just like we did and then plug those in. Okay, so that's your first little problem set for tonight. Any questions? Okay, let's move on to the last problem. You might end up with a little extra time. Okay, problem 2, analyzing a hyperbola from its equation. Okay, now what are the vertices, the foci, and asymptotes of the hyperbola with the equation 9y squared minus 7x squared equals 63. So now we get this long equation like we did this in another assignment, and I bet you already know what to do. Sketch the graph and then use a graphing calculator to check your sketch. And if you have a graphing calculator or a simulator, you can plug it in and see if they look the same, but we're not going to do that today. All right, so we know we've got something that looks similar, but not at all what we need, right? So let's start. We know the original equation has an equals 1, so let's fix that first. So divide everything by 63. And then we'll get the equals 1. So we'll get something minus something equals 1. Now let's simplify. So 9 does go into 63. It goes into itself once, and it goes into 63 7 times. And 7 goes into itself once, and it goes into 63 9 times. So now we've simplified that to fit our needs. So there it is. You're going to get y squared over 7 minus x squared over 9. So is this a horizontal or a vertical? It's a vertical because your y is first. And if you're looking at your numbers again, look, 7 is bigger than negative 9. So the larger number is always with the the one. Okay, so the hyperbola is vertical. The larger one is the y-axis. So it's vertical. Now, that would mean that you would use the, let me back up, you would use the vertical formulas, right? Oops. I'm trying to say. So, your vertices and your foci are both on the y-axis because it's one like this. Right? So what are they asking us for? What are the vertices, the foci, and the asymptotes? So we know that, well, let me just scroll it down. This is my a squared. That's my b squared. So my a squared is equal to 7, my b squared is equal to 9. So to get down to the a value, it's going to be positive negative square root of 7, right? Because a squared equals 7, take the square root of each side. And you get a equal positive negative 7. So our b is, take the square root of each side, positive negative 3. So now we can start answering the vertices, the foci, and the asymptotes. So c squared, now we're going to get our c value. C squared equals 7 plus 9, which is our a squared plus our b squared. So c is equal to positive negative 4, right? Because we took the square root of each side. 7 and 9 is 16. Square root of 16 is positive negative 4. So now we have our a value, our b value, and our c value. Now we can answer everything. So our vertices, and you would just go back to the chart, it's positive negative c. So 0, comma, positive negative radical 7. Our foci is, I'm sorry, vertices was a. That's your a value. Our foci is c. If I don't have it right in front of me, I get it wrong. All right, so there's your foci. It's your c value, the one we just solved for. And then your slopes, that's in that formula on that sheet. So it's radical 7 over 3, positive negative. There's your slope. But really, I just use those two values to calculate the box. And when you're drawing it, you can use the slopes if you want. But this is how you would get those slopes, right? So if you're going to have a calculator to figure out what is the square root of 7. But if you don't, think of, well, 3 times 3 is 9. Well, that's bigger than 7, so it's got to be smaller than 3. And 2 times 2 is 4, right? So it's going to be a lot closer to the 2 squared. So it's going to be 2 point something, right, over 3. And it comes out to actually 2.65 over 3. All right, so now you would graph all these things. All right, so you're going to plot your 4 and your 4 units away from the origin for your foci. I'm sorry, for your 4 is up here. Let me start that over. I'm messing up. All right, so these are all units of 2. So 3 would be there, and there's 4. So that's going to be 2.65, right? And then negative 2.65. There's your vertices. All right. Now, the foci are 0 and positive, negative 4, so I'll just put an X there and an X there. They didn't graph that on there. But our vertices are the important thing. Now you want to graph those lines, right? But you can also use the vertices and then the C value to get this, excuse me, I'm doing it again, your B value to get this side. And just draw your box if you don't want to graph those lines. And draw the lines through the corner of the box with your A and B values. And now draw your graph. So it's going to go like that and that. And that's how you draw your hyperbolas. Okay? So that's everything that you need to know for this assignment. So we've got time to do number 4 together, so let's do that. And your assignment tonight, let me go ahead and give it to you. It's 1 through 6, 8 and 9, and 14 and 15. So circle those now. 8 and 9, and 14 and 15. So these are on the back. And then 1 through 6 is the whole front side. All right, so now let's work number 4 together. It says find the vertices, the foci, and the asymptotes of each hyperbola, then sketch the graph. So I'm going to look at this first. X squared is first, so this is it horizontal or vertical? Horizontal. So I'm going to be using my horizontal formulas. So what is my vertices? Is that the A, B, or C?
Vertices are
A's. And then what is my B? It's going to give us that other axis that's perpendicular. Right. And then the C gives us our focus. So A is the vertex. Oops, there it is. So this is going to be my A squared. This is going to be my B squared, right? So now, that's just what I did right there. X squared over A squared minus Y squared over B squared. So that means that A is equal to is that wrong?
Yeah.
Okay, all right, well I'll finish this up when you guys walk out, and this will be on there. Sorry, I was watching. Have a good day, and I'll see you tomorrow. I'm glad I gave you the assignment. I'll pause it till. Okay, so to finish this up, excuse me. We've got our A squared and our B squared. So if A squared, move this up. A squared is 25 and B squared is 11, then A is positive negative 5 and B is positive negative square root of 11, or radical 11. So you know that your vertice is positive negative A and 0. And so it's positive negative 5 and 0. So there's your vertices at 5 and 0 and negative 5 and 0. So this is a horizontal, which we already knew because it was x. Minus x squared minus y squared. So our vertices are positive 5, negative 5, 0, and positive 5, 0. So there they are right there. And we're going to use the formula c squared equal a squared plus b squared to find c. So we're going to plug a and b in, or a squared and b squared in. And we're going to find that c is equal to positive negative 6. So now we've got our A, let me find it again, which was there, our B, and we've got our C. So now we need to write the vertices in here, so it's going to be 6 or negative 6 and 0 and 6 and 0. Alright, so there's your foci. This is our vertices. Oops. Okay. And now let's get our asymptotes. And it tells you right here it's y equals positive negative b over a times x. So we're going to have, I'm going to write it a little bigger down here underneath the box. It's going to be y equal positive negative, and b we know is positive negative square root 11 over 5x. Okay. And actually it would be more correct to do this. Positive negative goes out in front of our fraction here. Positive negative, radical 11 over 5x. And that's your answer. Okay? And remember, if you have your A and your B, on your major axis is your A, plot those, and then plot your B's. Draw your box, draw your lines through them. Those become your of course they're your vertex, and depending on if it's horizontal or vertical, then draw your graphs in, and that's how you graph them. Okay, that's everything other than giving you your assignment. So finish through 6 on the first page, and then do 8 and 9 on the back, and 14, 15 on the back. And that completes our chapter. Tomorrow you get a study guide, and then we'll go over it the following day, Wednesday, and then we'll test on Thursday. Thank you. This concludes our video.